Hello everyone. I have already started in my last video lecture, that is the topic flow and error control mechanism. We have already discussed about stop and wait ARQ. That is basically we know from sender to receiver side, one frame sent from the sender side. After that particular frame acknowledgement received by the sender, after that it send the another frame. Okay, we have already discussed in the last lecture. We have mentioned. Now the thing is, one thing is, after that basically in practical approach there have the bidirectional transmissions. Okay, now the thing is, bidirectional means full duplex method. Full duplex, what is full duplex method? That is both device, sender and receiver. Here we'll consider, suppose that is A and that is B. Two devices are there in these transmissions. Both can communicate with each other. That means if we consider A send a data frame F, that is F1 sent to B, that time we'll consider B as a receiver and A is a sender. Now the thing is, for bidirectional transmissions, B actually there have some data to send to A also. Okay, then B what to do? It must wait before it send the acknowledgement. It is received the data from its upper layer, and that particular data is combined with the acknowledgement of frame 1 that received by B. Now the thing is, basically it sent the data, suppose that is this is known as F0. It sends F0 and ACK1. What is the meaning of that? That is the thing, that is the meaning of F0 comma ACK1, that is B sending the frame 0 to A and ACK1, that means it is already received frame number 0, that is sending from A, and it is wanted right now for frame number 1. Same here, when A send the data F0, it is also sent, suppose ACK0. That means it is request frame number 0 from B, from this particular receiver, to send message, that is have to send from B. Now the thing is, that is actually combine the frame, but combine that particular link with data frame with acknowledgement. Okay, so that means here not require the total bandwidth is used for both the frame and acknowledgement, not require another link for that. Okay, so that is the thing. Suppose here the problem can arise, suppose that is A send data to B, that is F0, and request for frame number 0 from B. Now B is not sent immediately the acknowledgement ACK1, that is actually the meaning is frame 0 is received by the B. It must wait until its upper layer send the data to send to A. That means when B get the data frame 0 for A, that is combined with the acknowledgement and send it to B. Sorry, send it to A. Now the thing is, that particular time being, that is require some time to combine these two data with the acknowledgement. It may be quite possibility, suppose when we know from the stop and wait ARQ, every frame when sent to the receiver side, it first copy of this frame is recorded here and send the data and set a timer for this. Suppose before is acknowledgement received by A, the timer for that particular frame is expire. Then what happened? Then what happened? It is made the possibilities of resend the same duplicate data of F0. So that is the problem. But that particular process is known as the piggybacking. Why this is named so? Because of when two, that is bidirectional communications is there, both send data as well as acknowledgement, and here the thing is frame A send the data frame 0 and request for frame number 0 from B, and B doesn't send acknowledgement immediately when it received the frame number 0. It must wait before it received the frame number 0 from its upper level and send this is attached with the acknowledgement, that is it is received the frame number 0 from A and send it to A. Now the thing is A is delayed to get the acknowledged from the B. That particular delay is known as, that process is, that's why that particular delay, that particular process is known as the piggybacking. Okay, the next data packet to be delayed, that's why that is known as piggybacking. Okay, so what is the advantage of this piggybacking? That is the thing, most of all, maximum here one frame total link is divided into two different part, two different link was there. One link is used for towards the receiver, another is used for the acknowledgement, another link. But here both the combined, that use the total bandwidth used by frame as well as acknowledgement. So that is the advantage of this process, piggybacking process. Okay, now the thing is, what is the advantage of, we have already discussed the total part of the stop and wait ARQ. That is the thing, stop and wait we first, that is the advantage of stop and wait is no data can lose, because one data frame is sent, okay, after that particular frame acknowledged by the receiver, the sender, that's why second frame will be sent. So that means no data can lose from here. Okay, when first frame is acknowledged, then second frame is sent from the sender side. So that is the advantage of stop and wait ARQ. And what about the disadvantage of stop and wait? That is the thing, the disadvantage is, that is the time. Okay, the total time sender send the data frame, after that the waiting state is going on, the data is traversed towards the link received to the destination or receiver. That is the thing, that time sender send data to the destination that time, and receiver send the acknowledgement to the sender, that time is actually ideal for these transmissions. So that is actually wastage of time in this communication system, transmissions communications system. So that is the drawback of stop and wait. So for this problem, we'll go for next procedure, that is go back in ARQ. Now before we'll enter into the go back in ARQ, we'll consider, that is that two go back in ARQ and selective repeat ARQ are follow a different procedure but different protocol, that is known as the sliding window protocol. Sliding window protocol. Now firstly we'll discuss about what is sliding window protocol, then we'll go for next.